A star near our galaxy's central black hole is still forming dust and water despite extreme radiation. This is Fascinating Frontiers, episode 159. NASA's James Webb Space Telescope captured mid-infrared signatures of oxygen-rich silicate dust and water in the envelope around IRS-3. The star lies just over half a light-year from the supermassive black hole and is nearing the end of its life. Powerful stellar winds from similar cool, luminous stars normally shed gas that condenses into dust. The new data show this process continues even in the harsh environment close to Sagittarius A star. Similar huge stars shed dust-producing gas with their powerful stellar winds, yet the observations confirm dust formation persists near the black hole. Follow-up observations will track how much material survives to seed future star formation. Webb's detection of water and oxygen-rich dust around IRS-3 shows that even stars within half a light-year of Sagittarius A star can still build the raw materials for future planets and stars. The mid-infrared spectra reveal silicate features and water ice absorption that persist despite intense radiation and stellar winds from the galactic center. This survival suggests dust production channels remain viable in environments once thought too hostile. The next step is to measure how much of this material escapes the black hole's gravitational influence and joins the galactic reservoir. Picture a single teaspoon of the dust around IRS-3 scaled up to the volume of a city block. That tiny mass, spread across half a light-year, is enough to seed thousands of future solar systems. The mechanism begins when the aging star's powerful winds compress and cool its outer layers, allowing silicon and oxygen atoms to condense into solid grains before the material can be torn apart. Temperatures in these shielded pockets drop below 1000 Kelvin, even while the surrounding radiation field exceeds anything we experience on Earth. The grains then lock water molecules onto their surfaces, creating icy mantles that further protect the silicates. Yet the grains must thread a narrow path. Too close to the black hole and tidal forces shred them. Too far and they never form at all. Radiation pressure from the central engine can also accelerate the grains outward, but only if they survive the initial condensation phase. We still cannot explain why some envelopes retain measurable water while others at similar distances appear stripped bare. The precise balance between wind shielding and external irradiation remains an open puzzle that future multi-wavelength monitoring may resolve. Now the European Space Agency will air live coverage of today's total solar eclipse beginning at 1930 Central European summertime from the Observatorio Astrofísico de Javalambre in Spain. The path crosses Iceland in the afternoon local time and reaches Spain later, with totality visible across parts of the Northern Hemisphere. NASA will also stream views starting at 1:15 p.m. Eastern Time. The broadcast includes real-time imagery and expert commentary for viewers outside the path. Final rehearsal is underway at the Spanish Observatory ahead of the live transmission. Fingers crossed for clear skies wherever observers sit along the eclipse path. On a different note, a Falcon 9 lifted off from Vandenberg at 0446 UTC and successfully released 24 Starlink satellites into orbit. The mission marks another step in expanding the constellation's coverage at mid-latitudes. Telemetry confirmed all spacecraft separated cleanly and began commissioning. The launch adds to the ongoing build-out of the broadband network. Ground teams verified deployment through post-separation signals. Shifting focus, the prototype satellite launched in July 2025 had been steadily losing altitude until recent maneuvers reversed the decay. Amazon engineers executed a series of burns that raised the orbit and resumed raising operations. The recovery demonstrates the satellite's propulsion system can still function after extended low-orbit exposure. Observers had ridden the spacecraft off before the successful correction. Orbit raising efforts are now back on track. Next, the H3 upper stage delivered the navigation satellite into a 390 by 35,374 kilometers orbit at 22.9 degrees inclination. Ground tracking confirmed the orbit matches predictions for the quasi-zenith constellation. The successful insertion validates the H3's performance for future high-orbit missions. Catalog data now list both Michibiki 7 and the upper stage in the planned geotransfer path. Yesterday's launch is therefore confirmed as fully successful. Mike Finke is leaving the agency after 4 spaceflights, 549 days in orbit, and 9 spacewalks supporting the International Space Station. His career included long-duration expeditions and multiple shuttle missions. NASA noted that few individuals have shaped as many chapters of the agency's history. Finke supported construction and maintenance of the orbiting laboratory across multiple increments. The departure closes a 30-year chapter of direct flight and operational experience. New data from the Einstein probe showed the quasar flaring brightly in X-rays in 2024. Combined with more than 20 years of archival observations, the flare indicates the object can produce normal X-ray levels. The study, published in the Astrophysical Journal on July 28, removes PHL 1811 from the prototype class of X-ray weak quasars. For more than 2 decades, the source had been viewed as the defining example of intrinsically faint X-ray emission. The flare observation overturned that long-standing classification. The system pairs a close-in brown dwarf with a star that has already left the main sequence. The discovery highlights how such low-mass companions can survive the expansion phases of their host stars. Further radial velocity monitoring will refine the brown dwarf's mass and orbital period. The pairing is described as an unlikely couple given the evolutionary stage of the primary. Additional observations aim to pin down the exact separation and companion properties. The object provides evidence that rapidly growing black holes wrapped in dense gas can explain the mysterious little red dots seen in early JWST fields. Located at cosmic dawn, it shows the same spectral features as nearer examples. The find strengthens the case that these structures formed within the first few 100 million years after the Big Bang. Researchers at the Institute of Science and Technology Austria and collaborators published the result in Nature. The detection supplies the strongest evidence yet linking black hole stars to the puzzling yearly universe population. New images reveal clumpy material launched by the central star before it became a white dwarf. The clumps are now breaking apart and mixing with the surrounding interstellar medium. The observations trace how planetary nebulae enrich the galaxy with processed gas. The star at the heart of the helix powered a clumpy wind prior to its final collapse. Fresh imagery captures the ongoing dissolution of those ejected knots. With no moonlight to interfere, observers can expect a strong display of Perseid meteors this year. The shower's radiant lies in Perseus and remains visible through the night. Peak rates are forecast for the early morning hours of August 13. A new moon coincides with the maximum, removing the usual bright sky interference. Sky watchers anticipate favorable conditions across the northern hemisphere. The object does not match known categories of stars, galaxies, or transients in current surveys. Its spectrum and variability suggest physical processes not previously catalogued. Follow-up observations are underway to determine its distance and energy source. The discovery was announced through community channels after initial survey data were examined. No existing classification accommodates the observed properties. Commander Jeremy Hansen's comments underscore Canada's expanding contributions to Artemis and commercial low Earth orbit projects. Government and industry partnerships are increasing flight opportunities for Canadian hardware and personnel. The focus includes both lunar exploration and Earth orbit infrastructure. Hansen expressed pride in the nation's growing footprint across multiple programs. New bilateral agreements are opening additional crew and technology pathways. The interactive chart spans missions from OA02 in 1968 through upcoming telescopes such as SPHEREX. Each entry lists wavelength coverage, mirror size, launch date, and major results or failures. The resource allows users to compare how different wavebands have advanced over 5 decades. Roughly 330 individual events are annotated alongside the 76 missions. The timeline is hosted at every.app and remains open for community corrections. Before we go, keep an eye on follow-up spectra from that newly reported cosmic object, as observers work to pin down its distance and energy source. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. Quick tip from the network. Try Modern Investing Techniques next. Modern strategies for Canadian and US investors. Every NARA Network show is free at naranetwork.com. And on the website, every episode's visuals live in our free image gallery at naranetwork.com gallery. Royalty-free under Creative Commons. Download with attribution. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly